Welcome class to this video on section 7.1, Introduction to Graphing Quadratics. So we're starting a new unit. We're going to be looking at different kinds of equations than you've been used to so far. Up until now in your math education, you've been focusing strictly on linear relations. In the last unit, we did a little bit of the algebra that is useful for quadratics without explicitly relating it to what it looks like when it's in a graph. To get us started, we're going to start off with this handout here, do a problem, graph it, and then we can see what kind of graph we have when we do a quadratic. That kind of graph is called a parabola, and we'll see what that looks like in a moment. So let's read the problem together. It says you have been given 20 sections of chain link fence to reserve an area in a new park, which will be used as a wading pool in the future. The only instruction from the construction foreman was to reserve the biggest rectangular area possible. Alright, so to figure out what is the largest rectangular area possible, we're going to use this chart down below. And you can see it says rectangle label A, so that's the first one we're going to try. Imagine if the length of the pool is one section of the fence. So you can see the one section labeled here. And remember, it has to have two lengths, so that means you've used two sections of the fence. Now, imagine you had 20 sections of fence, you used two, you have 18 sections left. You have 18 sections with which to build the widths. And there are two widths. So if you do 18 divided by 2, you will get the length of the width, which you can see here, it's 9 sections. So you would fill in here 9 sections, and then what would be the area of the rectangle? You do 1 times 9, it equals to 9. And so we're going to fill this out, and I'll do the first couple with you, then I want you to try and do your own, and you can fast forward a little bit in the video and then see what it looks like at the very end. Alright, so if I do, for example, this one here, it's going to be 2 sections. 2 sections and 2 sections, that means I've used 4. That means I have 16 sections of fence left. If I divide 16 by 2, I get 8. And so then this is going to be 8 sections here. And what's going to be my area? My area is going to be 2 times 8, which gives me an area of 16 sections squared. Now, what if I do 3? And you should start to see the pattern at this point. 3 and 3. That means I've used 6 sections of fence. 20 subtract 6 gives me 14. 14 divided by 2, and that gives me 7. I have 7 sections of fence to use here. Alright, and then now, so I gotta put 7 and 7 here, and I do 3 times 7, and my area is 21 sections of fence. 21 sections squared of fence. Alright, do you see the pattern? 9, 8, 7. Can you guess what's next? That's right, it's going to be 6, 5, 4, 3, 2, and 1. Simple enough. And then if we're doing this over here, we're going to have rectangles that are 4, 6. This is going to be 5, 5, and 5. And really, what is that going to look like? And we'll make it look like that so you can see it. That's right. It's going to look like a square, which are 5 sections each. And then we're back to another rectangle, this time 6 and 4, like this. And then another one here, which is 7 and 3, 7 and 3. And then another one here, which is 8, 2, 2, 8. And then this should look familiar because it's the same one that we started with over here. In fact, all of these from F to I are duplicates, right? We just switched the length and the width. So now let's do the last column, and let's get the areas. So here we get 4 times 6 gives us 24. 5 times 5 gives us 25. And as I said, if you want, you can fast forward a little bit in the video if you don't want to watch me do each part of this, just so you can get the final chart. 5 times 5 is 25. 6 times 4, we're back to 24. 7 times 3, 21. 8 times 2, we get 16. And 9 times 1, we get it equal to 9. And we can see that we ended up where we started. Alright, so now let's fill in this part here. It says the maximum area of blank section squares occurred when the area is blank sections long and blank sections wide. Well, what's the answer here? What was the largest area we had? Here it is, 25. So we can write in here 25 sections squared. And it occurred when the area is 5 sections long and 5 sections wide. It was the shape of a square. Okay, so now that we've created that chart, there are 2 columns within the chart that are particularly important for us. That's the length of the pool and the area of the pool. Okay, and so I've captured them from the chart and brought them down so you'd be able to look at them as we put them into a graph. And why are these important? Because they give us the coordinates for a graph. You can see here, I'm going to have coordinates of 1 and 9. If you look at my graph, the length is our independent variable, x, and area is our dependent variable. So here is our x coordinate, here is our y coordinate, because 1 represents the length of the pool and y represents the area of the pool. So you can guess the next one. It's going to be 2 and 16, 3 and 21, 4 and 24, 5 and 25, 6 and 24, 7 and 21, 8 and 16, 9 and 9. Okay, and so those are coordinates that I'm now going to graph, and I'll use a different color for that. So let's find 1 and 9. If I graph 1 and 9, I'm going to find, if I look over here, so this is 2, 4, 6, 8. That means that 9, and this is here 1 and 9 is going to be right here. Right, 2, 4, 6, 8, which means that 9 is halfway in between 8 and 10. So we get our point for 9. And then what about our next one, 2 and 16? So again, if this is 12, 14, 16, then 2 and 16 is right here. And then 3 and 21 brings us right here. And then 4 and 24 takes us here. And then 5 and 25 brings us here. 6 and 24, here we go. 7 and 21. And 8 and 16. And 9 and 9. There you go. And when you see that, what you see there is what we call a parabola. And I can draw a line, and hopefully it's not too bad, but I can draw a line to show you what a parabola generally looks like. It should be curved, not pointy. Curved line like this. Here you have the parabola. So now we can answer some important questions about this parabola. That's what a parabola is going to look like. Let's talk about how it looks. We need to figure out the vertex. That's the first thing we're being asked for here. What is the vertex? The vertex is the highest or lowest point of the parabola. Okay, so what is the highest point? The highest point here is this. And what are the coordinates of that highest point? They are 5 and 25. In our problem, this means that when the length of the pool is 5, it has the largest area, which is 25. Now, does the parabola open up or does the parabola open down? Well, the parabola opens down. Do you see this is down? This is down here. It opens down. Okay, so we can circle down here. And if we look at the next one, it says this means we have if the parabola opens down, then we have either a minimum or maximum value with any parabola, and if the parabola opens down, then we have a maximum value, right? Because you can see the y values, they go up until they reach a certain point, a max, and then they go back down. Okay, so if you have a parabola which opens down, that means you have a maximum value. What is the maximum value? The maximum y value is 25. The line of symmetry occurs where the length of pool is. So let me erase this stuff here. The line of symmetry means the line you could draw which would divide this parabola directly in half. All right, so if I take my ruler here, so you see if I draw it here, is it going to be have two equal sides? No. If I draw it over here, no. If I draw it here, yes, it will have two equal sides. And so it's right here where my line of symmetry is. Okay, you see the line of symmetry there. And the line of symmetry is always going to be expressed as an equation that's like this. X equals, and it's the value of x at the vertex. So x equals 5. That is the line of symmetry. Now, what does this mean? Line of symmetry, as I said, it means that we have we divided the parabola directly in half, and that each side of it looks just like the other side. Okay? So since that's the case, that means we're going to have some points which are called symmetric points. And in this case, we'll label them all and we'll write a couple in there. So if you look here, here is one symmetric point. Here's one point, that's 1, 9. What point is it symmetric? Which point does it match with? It matches with 9, 9. So 1, 9 and 9, 9 are symmetric points. Here's another one, 2, 16. What does it match with? It matches with 8, 16. So those two are symmetric points. Can you see the pattern? And you can imagine these ones are also going to be symmetric points, and these ones at the top as well. Let's write the ones that are at the very top. So that's 4 and 24. We're going to write it in down here, 4 and 24. And then what is that symmetric with? That's symmetric with 6 and 24. So those are examples of symmetric points. All right, then now we need to look at the step pattern, and I'm going to need to erase some of this here so that we can get a better view of what the step pattern is. This is very important. There we go. All right, so the step pattern. If I were starting from the vertex, and we're always starting the step pattern from the vertex, here I would be starting from, okay? And I went like this, I made a step to the next point. How much did the y value, in this case, decrease by? It decreased by 1. Let's do another step from this point to the next point. So we went from 24 to 21. How much did the y value decrease by this time? It decreased by 3. Okay, what about the next step? 21, and we went down to 16. How much did it decrease by now? It decreased by 5. So this is the step pattern, 1, 3, 5. And it's actually -1, -3, -5, okay? Because it went down. It went down 1, it went down 3, it went down 5. What about the more general step pattern? Well, the more general step pattern is 1 times A, 3 times A, and 5 times a. And I'm going to show you what that means right now. Okay, so what you see on the screen now are 3 quadratic equations, which I'm going to use along with their table of values to explain the step pattern and to explain how we can use the more general step pattern to find the step pattern for other equations. The most basic quadratic equation is y equals x squared. And we're going to do calculations and fill out this table of values and then see the step pattern. So let's start from from 0. Okay, and for this case, that is going to be our vertex, though it's not always the vertex, but I'm telling you it's going to be the vertex in this case. So we're going to start from 0. And if we do 0, if we put in 0 for x right here, then we do 0 squared, what would we get? We'd get 0. Very good. Now we do -1 replacing x, and we would get -1 squared, which would just give us 1. And then we do -2 squared, and that would give us 4. -3 squared, that would give us 9. Now if we go the opposite way down here at the bottom below, 1 squared, we're going to get the same number, 1. 2 squared, we're going to get 4. 3 squared, we're going to get 9. I wonder if you can see the step pattern already. If not, here it is. Starting from the vertex, that's where we start our step pattern. We have a difference of 1. And when we read, we usually read from top to bottom. So actually the difference here is -1, right? Because we went from 1 to 0. Okay. And what about if we go from here, 4 down to 1? That means we get -3. And what if we go down here, we get 9 subtract 4, we get 5. Can everyone see? Now we have 5, 3, 1, or 1, 3, 5 if we start from the vertex. And what about over here? Well, we went from 0 to 1, so we went up 1. From 1 to 4, we went up 3. And we went from 4 to 9, we went up 5. There's your step pattern, 1, 3, 5. And so the part I'm trying to now have you understand is this here, the more general step pattern, and then how we can use it. What about in this case where we have 2x squared? In this case, our step pattern is going to change a little bit. Our step pattern is going to need to be multiplied by 2, and I've already written it out for you over here. So do you see the normal step pattern was 1, but 1 times a, in this case, a is going to be 2. So 1 times 2, we get 2. 3 times 2, because 3 times a, we get 6. 5 times 2, because a is 2. 5 times 2, we get 10. All right, so that's going to change our step pattern. Let's look at how that works. Let's start from our vertex. Again, I'm telling you that this is the vertex. You don't always know that the vertex doesn't have to be always, the value of x doesn't always have to be 0 at the vertex. But this is the vertex here, so we do 0. And what would our step pattern be? Let's use the step pattern to find out. Instead of doing all the calculations, we're going to use the step pattern to find the rest of the values in this table of values. Well, look here, when we went up, we went down -1 or up 1, depending on which direction you're looking for. But we have to multiply that by 2, so that's going to become -2. And we have to multiply this by 2, so that's going to become -6. And we're going to multiply this by 2, and that's going to become -10. Okay? And so what that means is, this is going to be 2, because we're adding 2, and if you think of it, we're going down 2 from 2 to 0, right? And we have to add 6 to get this next number, and that gives us 8. And if we added 6 to get to 8, which means if you go from 8 to 2, you're going down 6, as you can see here, -6. And then here we're going to add 10. And so then we get 18. And you can see from 18 to 8 is -10. We subtracted 10. All right? And then the pattern repeats itself. And so I could know that here is going to be 2, 6, and 10, and these are positive, right? Because now we're going to go from 0 to 2, that goes up 2. From 2 to 8, 2 plus 6 gives us 8. 8 plus 10 gives us 18. Okay, so you see we used the step pattern to figure out the values. We didn't have to use the equation. What about if the value of A is 0.5? Again, you're going to take the basic step pattern 1, 3, 5, and you're going to multiply each of them by 0.5 to find the new pattern. So if I do 1 times 0.5, I get 0.5. 3 times 0.5, I get 1.5. 5 times 0.5, and I get 2.5. Now I can come back over here, starting from my vertex, and I can draw in these here to show the first differences. And again, this is the vertex, and again, not always the vertex. In this case, it is the vertex. And I'm now need to find out how much is this one here going to change by. Well, originally it changed by -1, or -1. So this time it's going to change by -0.5, because 1 times 0.5 is -1 times 0.5 is -0.5. And how about in this case, I times it by 0.5, what do I get? It's going to change by 1.5, -1.5. And then here times by 0.5, and it's going to change by -2.5. All right, so there's our step pattern, and I'll write that in just a tad bit neater. So we have -0.5, -1.5, -2.5. Now, for our purposes, when we're going from the vertex from here up to here, we're going to be adding, right? But you can see that as we read it downwards, it's subtracting. So if I'm at 0 and I go up 0.5, then that takes me to 0.5. And if I'm at 0.5 and I go up 1.5, I get to 2. And if I'm at 2 and I add 2.5, I get to 4.5. And then again, you can see it's subtraction. 4.5 minus 2.5 gave me 2. 2 minus 1.5 gave me 0.5. 0.5 minus 0.5 gave me 0. And then the pattern repeats itself on this end, and these are all positive. And 2.5. All right, and then we can fill these in, 2 and 4.5. Okay, so that's how you can use the step pattern, and that's what this last part here means about the general step pattern. I'll give you one other example on the other handout, and then we'll be finished. So now we're going to work on how to use the step pattern to complete tables of values, and we just did a brief run of this. This table of values right here is the same one you literally just did moments ago. And it's y equals x squared, which is the basic quadratic equation, and it's going to follow the basic pattern, which we've discussed already, which is 1, 3, 5, and the pattern is 1, 3, 5. It's going up by 2. It continues 7, 9, 11, and so on and so on. And we can use this pattern in order to figure out the next values. So if we look here, we can find all the first differences here, and we can use it. What's the difference between 0 and 1? 1. What's the difference between 0 and 1? 1. Okay, we'll change the values positive or negative in a moment, but right now we can see there's 1 and 1. There's a difference of 1 between 0 and 1 and 0 and 1. Now, that's where I got that 1 from. I can see it. Now I follow the pattern. Here's 3, so this has got to be 3. I follow the pattern, so now we have 5. 1, 3, 5. And then on the other side, exact same, 1, 3, 5. So this is 4, this is 9, this is 4, and this is 9. Literally, we just did that. I just wanted to show you again that pattern. So what about, though, when we have, let's do the second one here, and we can see here this is a difference of 2, right? If this is a difference of 2, what it means is that it's not 1. That means our pattern is slightly different, right? And what did we have to do to this 1, to get to 2? We had to multiply by 2, which means we have to multiply all the terms in the pattern 1, 3, 5, 7, 9 by 2. So I'm going to write, and as a habit, you should write out the base pattern over here, okay? And we multiply by 2 every part of the pattern. And what do we get when we do 1 times 2? We get 2. 3 times 2, we get 6. 5 times 2, we get 10. 7 times 2, we get 14. 9 times 2, we get 18. Okay? So now what you should notice is there was a change of 2 here. So what's this change going to be? This change, if we follow the pattern, is going to be 6. Over here, remember, so this went down 2 here. We got to go down this direction 2 as well. Okay? The pattern repeats itself, and the signs change, as you'll see in a moment. And so what I should get in this box right here is 18 as well. Okay? You can see 18 would be symmetrical with 18. So then, if I follow my pattern, so 2, 6, 2, and then this has got to be also 6. And then this is going to be, following the pattern, 10. This is going to be 14. All right? Now notice that from 20 to 18, I went down. I went down from 20 to 18, I went down. So I have to go down from 18, 6 in this case, and that's going to take me to 12. And then I have to go down another 10, and that's going to take me to 2. And then I have to go down 14, and that's going to take me to negative 12. On the bottom part of this, it was 18. I got to subtract 6. That takes me to 12. All right, so actually I'm going to do just one more, and you'll get hopefully a stronger sense, and you want to complete all these handouts that are like this. So here in this case, again, we're going to write our pattern 1, 3, 5, 7, 9. And then we find our vertex. Now our vertex, what we know about our vertex is that at our vertex, either side of the vertex is going to have the same y value, right? And you can see that here. So look, see, there's the vertex, then it was 1 and 1. Here's the vertex, and it was 18 and 18. So because I recognize that pattern, I can know that 2 and 16, that's my vertex. Now how much? What's the first step from 16 to 19? It was 3. What's the first step here? 3. So that means that I'm going to have to multiply everything in the pattern by 3. Times 3, times 3, times 3, times 3, times 3. And then we can write down what our new pattern is going to be. It's going to be 3, 9, 15, 21, and 27. That's our new pattern. Which means, and I'll continue with the color coding I've been using, so this is 3 and this is 3, which means this here is going to be 9. This here is going to be 9, 15, 21. Now let's look at the direction it's going. 16 to 19, we had to add 3, which means we're going to add 9 in this case, and we're going to get 28. And then we're going to add 15, and we're going to get 43. And we're going to add 21, and we're going to get 64. Again, if we're looking from this direction, it's going up. And so I'm going to add 9 from 19, and I'm going to get 28. All right, so now that you've seen that, you should be able to complete this last one, and you should be able to complete the other handouts that are just like it. I am actually very quickly going to actually make a small edit here to what I've done, because the values are actually important. If I'm reading this downward, let's look at this first one here. I'm reading it downward. This is 9 to 4, that's negative 5. 4 to 1, I'm going down 3. 1 to 0, I'm going down 1. And then it's plus 1, plus 3, plus 5. Over here, if I'm at negative 12 and I go to 2, I'm going up 14, so that stays as positive 14. I'm going up 10, I'm going up 6, I'm going up 2, but then I go down 2, then I go down 6. Okay, so these values here would be negative 2 and negative 6. Here, if I go 29 to 19, I go down 9, I go down 3, I go down 3, I go up 3, I go up 9, up 15, up 21. So you can see negative 9, negative 3, positive 9, positive 15, positive 21. The signs are important, and you're going to see that when we analyze first and then second differences later on in the course. So that concludes this video. You should have everything you need to be able to complete all the handouts. Sorry that it's a longer video than normal. It's just the introduction to a unit, and so there's a little more to explain than usual. Good luck with your work.